How's it going, you guys? So in this video I wanted to discuss pedigrees, specifically some tricks on how to figure out what pattern of inheritance a pedigree follows, whether that's autosomal dominant, autosomal recessive, sex-linked dominant, or sex-linked recessive. So I kind of want to go through some tricks on how to figure that out. So this video is already making the assumption that you know a little bit about pedigrees. So let's just jump into it. So the first thing that I would recommend that you do, is eliminate Y-linked as a possibility. So some traits, not that many, but some traits can be found on the Y chromosome, or the genes responsible for that trait. So if it only affects males, then it's possible that it could be Y-linked. But if we can eliminate Y-linked as a possibility by finding at least one female who is affected, then we can cross that off the list and it makes our lives easier. So try to eliminate Y-linked. It's fairly simple. Look for females that are affected with the trait. They're shaded in. The second one, dominant or recessive. So this one is slightly trickier. It's not as simple as just seeing a dominant or an affected female. So what I would recommend you do for dominant versus recessive is look for situations where the parents are the same and the child is different. So for example, if you see something like this on a pedigree, where you have a circle, female, that is shaded in, and a male that is also shaded in, they have a marriage line, so they get married and have a child, and the child is unaffected. In those circumstances, we know the trait has to be dominant. We don't know if it's dominant just by seeing two affected and an unaffected child. We don't know if it's X-linked dominant or autosomal dominant, but we know it's dominant. That's because if it were recessive, you could not have two recessive individuals have a dominant offspring. So in this situation, where the parents are shaded in and the child is not, we know the trait is dominant. Now, using that same logic, if you have two parents that are not shaded in, so they're unaffected, and you have a child that is affected, you know that the shaded in trait that you're looking at is recessive. And this is because, again, if this were the dominant trait, and these two did not have the dominant trait, that means they are recessive. You cannot have two recessive parents have a dominant child, have a dominant offspring. So in that case, if you have two parents that are unshaded and the child is shaded, the trait is recessive. If you have two parents that are shaded and the child is unshaded, the trait is dominant. And these two might be carriers of the trait, of the recessive allele, sorry. So hopefully that is a trick that you guys can use to eliminate either recessive or dominant. So let's say we figured it out. We figured out that it's dominant. Now we want to look for other things to narrow down X-linked or autosomal. So what I would do to figure out if it's X-linked or autosomal is look for a father who is one thing and a daughter who's another thing, so they're opposites, or a mother who is one thing and a son who is another thing. So you could have perhaps shaded mother, unshaded son, or unshaded father, shaded daughter. So something like that. And then after you figure that out, go ahead and test it to see if it works with an X-linked trait. The goal here is to eliminate X-linked as a possibility. You cannot really eliminate autosomal because even if X-linked works, chances are for most pedigrees, autosomal will also work. So if you have an X-linked recessive pedigree, I guarantee you, or I can't guarantee you, but I almost guarantee you that an autosomal recessive trait could also work for that pedigree. So trying to eliminate X-linked is the name of the game. So let's look at this. Here we have a father who's affected and a daughter who is unaffected. And here we have a mother who's unaffected and a son who is affected. So we have opposites here. What I would say is, let's say we already eliminated or already decided that it is dominant. So we know it's a dominant trait based on the trick that we just learned. So if it's dominant, we want to try to, X-linked recessive and autosomal recessive aren't possible. But X-linked dominant and autosomal dominant are. So we want to try to eliminate X-linked dominant. So what we're going to do is we're going to test it. Let's say we take this father and this daughter. The father, if this is X-linked dominant, has to be X with the dominant allele, so we'll say capital T, X capital T, and since we're trying to make the assumption that it's X-linked, the other chromosome that the father has is Y. So it's X big T Y. That's the only possible genotype that this father could have if it is a shaded male. Same thing with the son. Has to be X big T Y. Now, if you have an unshaded female, it has to be X little t, because we've established that it's dominant. So if it's X-linked dominant and it's not shaded, it has to be X little t, X little t. In that case, if you see this, a shaded father with an unshaded daughter, this is not possible because the father didn't give a Y to the daughter, had to give an X big T to the daughter, but this daughter has no X big T's, otherwise she would also be shaded. So in this circumstance, it cannot be X-linked dominant because we have an affected father with an unaffected daughter. It would also work for this one. If we had an affected son who's X big T, Y, and we have an unaffected mother who has to be X little t, if it was X-linked dominant, let me fix that T. That would also not work because the Y comes from the father, this X has to come from the mother has no X dominant uppercase T to give, so therefore that is not possible if this is X-linked dominant. So we figured out that it's dominant using the other trick. We eliminated X-linked dominant, so therefore it has to be autosomal dominant for whatever that trait is. If we figured out it's recessive, and we see something like this, we will be able to eliminate X-linked recessive. So here, let's assume that we figured out that it's recessive. We want to find a mother who's one thing and a son who's another thing, or a father who's one thing and a daughter who's another thing. So here we have an affected mother with an unaffected son. So if this is recessive, again, these females, the only possible genotype they can have is X little t, X little t. If they had an X big T, X little t, or an X big T, X big T, they would not be shaded in because they wouldn't show the recessive trait. And so the two gentlemen here would have to be X big T, Y, X big T, Y, because if they're not shaded in and this is an X-linked recessive trait, then they have to have the dominant trait. So X big T, Y. Now, again, this is not possible because X little t could not make an X big T son because the Y is coming from the father, X is coming from the mother. And an X big T, Y father could not have a daughter that's X little t, because that big T is what he would pass on, not the Y. So in this case, it is not X-linked recessive. So generally speaking, to quickly figure out what pattern of inheritance a pedigree follows, eliminate Y-linked by finding an affected female. Figure out if it's autosomal, or figure out if it's dominant or recessive by finding two parents that are one thing and a child who's another thing, and then figure out whether it's X-linked dominant or autosomal dominant, or X-linked recessive or autosomal recessive by finding a parent that is one thing, a mother specifically, and a son, or a father and daughter relationship where they are opposites. And then test it. So let's put this into practice. So we're going to go over to this pedigree. So this is a pedigree that was actually on an AP question. So I decided to pull this, and they asked the person to figure out whether or not it's X-linked, autosomal, whether it's recessive or dominant. So let's use our tricks. Let's first say, is it Y-linked? Well, it's not Y-linked because we see some affected females. Since females are XX, having this many affected females would be almost impossible if it were a Y-linked trait. So we can eliminate Y-linked. So I'll put these steps over here. Y-linked. So we can eliminate Y-linked as a possibility. So step 2, is it dominant? Is it dominant or recessive? So looking at this pedigree, we want to find 2 parents that are the same and a child who is different. So it looks like the only spot where we see that is right here, where we have a father and a mother in the 2nd generation having a child who is unaffected while both of the parents are affected. So this tells us that it is dominant. So this must be a dominant trait. And again, why is it dominant? Because if this were recessive, it would be impossible to have 2 recessive parents end up having a dominant offspring, dominant child, right? So these have to be dominant, and this has to be recessive because sometimes recessive traits skip a generation. So has to be dominant. Now, is it X-linked dominant, or is it X-linked, or is it autosomal dominant? So now we have to figure out step 3, is it X-linked? And sometimes the College Board just calls this, or the AP exam just calls it sex-linked. So sex-linked or autosomal, or autosomal. So we figured out its dominance. So now, X-linked or autosomal. Again, your goal should be to eliminate X-linked as a possibility. The reason is because if X-linked works, chances are autosomal also works. So the goal is to try to eliminate X-linked. How do we do that? Well, we're looking for opposites across parents and children. So we want to find a dad that's one thing, and a daughter that's another thing, or a mother that's one thing, and a son that's another thing. So let's see if we can figure that. I see a couple of these. So here, I see a mother and a son who are opposites. So let's test that. If we look at this one, the mother, if this is in fact X-linked dominant, this is the dominant trait, the shaded ones, the son has to be X big T Y. And that's the only possible genotype that the son could have if we're using T's. So X big T Y. Now, the mother is not shaded in, so she doesn't have the dominant trait. So if this were X-linked, it would be X little t, X little t. She would have to have 2 recessive alleles. So in this circumstance, this would not be possible because we have an X little t and an X big T. That X big T had to come from somewhere. Wasn't the dad because the dad gave the Y. So this is not possible. So therefore, we can eliminate X-linked dominant as a possibility. So therefore, it has to be autosomal dominant. Autosomal dominant. So hopefully that was helpful. You might have been able to figure it out in other ways too. I do want to point out that here, if you had chosen this, a mother who's affected and a son who's unaffected, it follows the whole a mother being one thing and the son being another thing. But if you try to use that to justify that it's not X-linked, it probably would, well, it wouldn't have worked. And that's because the son would have to be X little ty if he is unshaded, and the mother has to have an X big T, but she could very well be a carrier of the X little t. So it's possible that the dad passed on the Y, the mother passed on her kind of covered up X little t, and that's why you have a recessive son like that. So this would have worked for the X-linked dominant trait, but then if you can't eliminate X-linked one way, try to eliminate it in another way. So again, you want to eliminate X-linked because chances are if it's X-linked, it also works for autosomal. So hopefully that video was helpful, and if you have any questions, just let me know.